Hello, Shannon. Okay, Mark is going to be back with us in just a second, and we will be on air soon with Shannon. All right, hello, hello.
Hello.
All right, hello, hello. How are you?
Pretty good. How are you?
I'm fine. I want to, hey, hi. You know, we haven't talked in so long. I was just thinking, I started growing my beard the last time we talked.
I was like, who is this guy?
All right, good. We've been having some great sessions. I don't know if you've had time to look at any, but some of the stuff has been pretty incredible. Wicket was just on, and he only mentioned you at least 8 times.
We just talked yesterday.
Oh, that's cool. That's cool. What are you going to talk about today?
Red Team and Nexus.
Excellent. Can I just turn it over to you and you can do your stuff?
Sure, no problem. Sounds good.
All right.
All righty, daddy. Let me see here. If I remember how to press all the buttons in the right order, we'll be going at the same time. Okie dokie. So let's see. I have my presentation. We all know that I love Google Docs. All right. Can you see it?
Yep, looking good.
Fabulous. So, hi, I'm Shannon Lietz. I am one of the founders of DevSecOps. A little bit about me. I've been working on Software Safer Sooner for quite some time. Started in the industry as a developer / security professional. I like to build comic strips and also recently started something called Hacker Girl. And I think you'll see more about that as I continue to ramp it up with some of my cohorts in the industry. So super excited to be here. I'm a big fan of Mark Miller, Derek Weeks, Sonatype, lots of fun that we've been having over the years. And want to talk a little bit today about DevSecOps. So I thought I'd get started with something that Simon Wardley sort of invented, which is a Wardley map. And wanted to talk about a little bit about like what the heck is happening out there. Why is this red teamer talking about Nexus? Like what is going on in this world? And so if you kind of look at a Wordly map, what it helps you to understand is sort of how to predict the future. And what's great about that is for people like me, it sort of explains the genesis of ideas. I tend to be on the bleeding edge of things and always end up feeling like people don't quite understand. So you can imagine that trying to make things come together is really about telling a story. And in this case, when you're building a story around things like CI/CD and the changes that are coming with the cloud, you really kind of hone in on where pain points start. And while most pain points started with traditional compute and building applications in data centers and how slow things were coming about, and just from the standpoint of application development, customers demanding better things and more stuff. And so you can imagine that that meant that Agile got born in the early 2000s. And well, that had a profound effect on compute, one that was actually really interesting. Agile basically needed the ability for us to publish code faster. And so the pipeline of what is now the cloud actually got started. So a little bit of automation here. And so compute kind of translated into cloud. From cloud, we ended up basically shifting in terms of security. And so there's a profound effect between the cloud and DevSecOps and Agile and some of these different things that have been happening. I'm also a big fan of DevOps and really trying to figure out how to build better practices around application development. I love the idea that we can actually connect the dots between development and operations, 24/7 capabilities. And so, if you kind of build on from the fact that compute didn't work, cloud got born, you also saw shifts around compliance, and now compliance as code is really becoming the bigger thing. You're seeing some of the cloud providers out there like AWS, GCP, and Azure include more security capabilities that are around compliance measures being built in. And that's a big advantage because compliance is really difficult. There's lots of requirements, and trying to make sure that we're doing the right things in our applications is really important when you're dealing with regulations. Another thing to think about is like penetration testing really kind of is an interesting concept. There's been a lot of that over the years. I've been in this industry for like 30 years, so you can imagine I've seen it all. And when that stopped working with some of the ephemeral workloads, because a point-in-time assessment is not all that great when you're doing code deployments on a daily basis, red teaming became sort of an interest and an attraction. And there's ways to practice red teaming. I would say we do extreme red teaming. We're kind of a red team X, if you will, where I work. And so I think that this is really becoming more of the norm. And you'll see a lot more red team tools emerge and some of the commoditization there. And then, finally, like traditional security really has been working its way towards DevSecOps over the last couple of years. And we're seeing more and more practitioners really understanding that for them to do the right things for their organizations, to have software safer sooner, you've got to start to lean into the development and CI/CD pipelines, which sort of transcends. And I would say that this also gave me a pause back in the day when we started doing some of this work across many of the companies I've worked at. And so the way that I look at this is it was very much at the time that it started, sort of something that went from this checklist of things that people had to do in security towards this moment of realization that the checklist wasn't working, that things couldn't just be figured out, that somehow we actually had to emerge. And really that gave pause to the head banging moment, if you will, that led to sort of this evolution in thinking from a security perspective, and really is the reason why we started DevSecOps. I can tell you that a lot of the angst, the heartache, I wish there had been some people that had gone before us, because we really learned the hard way that it required us to think a lot different as security practitioners. And over the years, I've gotten a chance to work with a lot of great security practitioners, and some of them have said, well, with DevOps, security has really kind of gone by the wayside. And one of the greatest things that I've heard recently was, John Willis talking about how security is just too important to leave out of DevOps. And so the natural evolution to DevSecOps is something that we really need in the industry, in the software that we build, so that we can start to really evolve our capabilities, meet more of the customer demands that are out there, and also make sure that we're also building in the trust required to keep those applications alive long term. So if you kind of follow through this thread, the head banging moment occurred. So really what emerged from that was, well, what if we start thinking about how we're going to evolve over time? And so the natural evolution started with sort of the burp, or what do we call kind of the insanity moment of lots of surprises. Skills need to be developed for every job function. Developers had to build security skills, and security had to build dev skills. And well, ops had to build all of those, so did everybody else have to build ops skills. And so you can kind of imagine this is an emerging capability that we've all been thinking about. The maturity model that you're seeing here is really around behavioral maturity. When you're in an environment, you could say what the things are to prescribe, but in reality, the truth is that you'll know you're living in an environment that's actually maturing from a DevSecOps perspective when you really start to see the culture shift. There's a lot more context and decisions. People are talking about security, but they're not just saying security. They're talking about things like kill chain. They're talking about CVEs, proof of concept code, exploits. And, executives are part of that process. Your company's evolving when you start to see some of these things come to life on a daily basis, part of your OpMex. And why is that all really important? Why is that part of a Nexus conference? Well, I think the reason why is because when it comes down to it, software gets built by developers. I would say that I got started as a developer. I quickly shifted over to security because it became just super interesting for me. I'm kind of a anti-engineering person. I like to break things. I'm also a creative, which means I like to break things in weird ways. And so you can imagine that lent itself to building a really big, extreme red team here at Intuit. And what that allowed us to do from an emerging perspective is to look at things in a little bit of a different way and kind of shift towards looking at the CI/CD pipeline. So this is a picture I've put up many years now. And what I'd say is, like, how hard could it possibly be to put security into a CI/CD? And there's lots of code capabilities out there. You have to, build your code. You have to basically deploy it, and somewhere in here, a security professional has to figure out how they're going to map all their security capabilities into it. And so the cool part about a CI/CD pipeline is there's lots of products that you could choose, but a lot of them are one for one on this process of being able to develop code, be able to integrate it, test and scan it, build and deploy it, and really monitor it. And so the end-to-end lifecycle is pretty clean when it comes to having lots of options for products that are out there that fit into this pipeline. On the counter side, the security side is kind of messy. And so if you look at DevSecOps as code pipeline and putting trust back into your code, there's a lot of myriad of tools, and they have to kind of be strung together. And there's lots of very small patterns around how code becomes security degraded over time, and how you're going to actually spot inspect security degraded code is really a challenge. Figuring out and moving and shifting left is really about shifting your mindset left, as opposed to thinking that you're going to make something perfect and it's going to travel down the pipeline with speed. That may not actually be what we're talking about when it comes to really evolving your practice around software being safe. And so the idea is, what spot inspections do you need to be able to deal with the code that you're building specific to your organization is part of the mindset of how you put things together. So, everybody said to me, well, you run a red team, which means you wait for this whole thing to get done, and then all of a sudden you're, pounding the snot out of code and you break it, and then it goes back through this pipeline. Isn't that the thought process of shift left? And what I've told people for many years is that actually a good red team is very early on in looking at source code, early to look for exploitable code, building things like, we have something called Rebel that basically looks for exploitable code within source code repository, looking at how we're going to pull things together. So today what I wanted to do is, this is a Nexus user conference. I wanted to highlight the area around artifacts. And I think that that's a really important thing, because there's a little bit of a nuance when it comes to a red teamer who thinks about what a pipeline looks like and how they might actually leverage the information coming out of something, say, like Nexus. So today we're going to talk a little bit about, how does Nexus fit into the red team world, and why do we like it, and what does it do for us? The artifact repository is a #1 candidate for where you might find things that you can test and break from a security perspective. So it's a place where you have to have a really good secure repository, but secondarily, it's also a place where you're actually sharing between many different teams earlier than deployment, and it gives you the ability to share code that can be sort of broken into, and then later that information brought to life. What's great about Nexus is they also have some products and capabilities that allow you to not have to have necessarily a huge red team to do some of these things. You can actually spot your capability inside of Nexus, and then actually get information about whether or not the things that you have inside of your artifact are secure enough. And so I thought there was a great thought process around this, which is, security is really about degradation, and I think repository for an artifact is really important, because you can actually check to see how your code's performing by the way in which it's actually being evaluated. And since source code actually degrades over time and applications degrade over time, wouldn't you want to have the information that you need sooner than later to be able to evaluate within your pipeline when you're going to do a security recall? So you can imagine that means that a company that gets closer to its artifacts and is able to look for things like CVEs and interest from the community on those artifacts and the libraries that are being leveraged within software, it means that you're getting a little bit of a pulse early on ahead of when you might publish something that does have an opportunity. So we're really, we're very much adversary obsessed. And when you're adversary obsessed, things like this chart actually represent communal interest around a specific component part. And to look for component parts, you actually really have to have a different viewpoint. So for us, just kind of going to some of the Sonatype capabilities, there's a capability within the product that has the ability for you to see the vulnerabilities and security issues associated with your artifacts. And what's great about that is it gives you a threat level. There's an identifier for whether or not you have a CVE, or in this case, Sonatype also does some of their own research where they create their own problem codes. And that allows you to see some of the things that are interesting around code. It gives you a little bit more protection because it's not just CVEs that they look into, but also in addition, just kind of framing their research. They're looking at things that are maybe even scary that don't necessarily have a CVE rating yet. So it can be quite interesting. Now, from a red team perspective, this data is actually super interesting because a shift left element of a red team practitioner is that they're looking for things that could be exploitable so that they can find a way to actually demonstrate that the code that's actually being deployed is weak in a variety of ways. So from the anti-engineering perspective, looking at something like this, I might actually start to analyze and say, well, from a red team perspective, that commons collections library looks to be really interesting. What could I do with it? And generally what that leads to in most environments is that you can do things like build up POCs. A POC is a proof of concept. On the breaker side, even breakers actually write code. They just write code that basically does things to applications that it shouldn't be allowed to do. And so sometimes there are mistakes that are built into applications. There is no such thing as perfect software. And I think that what's really interesting is that when we talk about shift left, there's this concept within the community around that we're going to build things to be more perfect earlier on. And what I would tell you is actually what you want to do is you want to find mistakes faster within your pipeline, highlight them, and be able to get to fixing those mistakes that might provide opportunities to bad guys. Now, what I will also tell you is we tend to spend a lot of time as a red team in the red area of these charts. And the reason why is because those commonly are the areas where you might find exploits within an environment and not just have to patch something to patch it, but actually really leverage the ability to patch things that are most important. So when something's rated critical, it's probably going to have a exploitable POC that can actually create a way for a bad guy to be able to break into your systems, your software, gain access to data. And those are bad things that we all want to prevent. So you can imagine as you're looking through this, it's really easy to prioritize. A red teamer can leverage this just like an application developer. So now we actually have a way to have common language between a security team and an application team, which is just magic into itself. So why is that all important? Like as a red teamer, we get interested in different things. Back in the day when I started doing red teaming, it was all about how fancy could I be in breaking into something so that I could help build a bit of shock and awe, if you will, to get people to do the right things, because it was all about trying to bring the adversary to life because they're very difficult to find. In this case, you're seeing here a little bit of a, I said I like to do comic strips earlier on in this discussion. This is my view of how a customer or consumer might actually get to see what security looks like to them. And in this security facts label, because I was at the time looking at a nutrition facts label, I thought, well, why not? You can see that this particular application might be interesting. What's great about a label like this is that there's this notion of adversary interest. I kind of say that this is the notion that when a tree falls in the woods and no one's there to hear it, did the tree actually fall? And the reason why that's an interesting concept is that we have tons of different ways that an application could have mistakes or problems within it. And ultimately, what determines the risk associated with an application having a defect is that an adversary has to be interested and they have to want to do something with that particular opportunity to convert it into a compromise or a breach. And so that's something to keep in mind as you're thinking about how you might apply the code capabilities within Nexus. Now, we all know that it would be great to understand adversaries, and not everybody's going to spend a ton of time on the underground trying to figure out what an adversary is interested about. So what's really ideal is that the codes that the companies create around CVEs and research tend to lead themselves towards actual POCs that can be gathered by a red team individual and played against the company. So having a mental model and being able to really move forward with, say, a CVE that comes out of Nexus is about actually applying some frameworks. In this case, you could take the Lockheed kill chain model and then the MITRE KPEC model and the MITRE attack model, kind of forge them all together. And ultimately, at some point, you might even leverage things like AIML to predict the targets that might be most interesting to an adversary so that you can test them ahead. This means that in your pipeline, you have to have the information associated with exploiting code that's already been created so that you have a pattern of being able to identify those targets and opportunities that a bad guy might use. So these are, how do you find a needle in a haystack? Sometimes it's really about how do you actually leverage the tools within the pipeline to be able to find those needles and ultimately highlight them so that they can be leveraged. Now, as a developer, what I love is that I can go to one place and actually look up what a red team view is of the code that actually might be within the libraries of my application. And sometimes what's really interesting about Nexus is there's a drill down feature, so you can see where dependencies might have dependencies that are actually foul as well. And so I think that that's really the benefit of being able to pull some of the security into a CI/CD pipeline, is that you have interest from the security community and you have an understanding, because the tools actually bring security features and development features together into one place where it can be shared. I'm a big collaborator, and I like to collaborate on similar information so that you don't have to quite explain it all the time. That can actually lower the friction for the security team to continue to chase the actual things that might get exploited and highlight risks that are near-term versus long-term. When you're kind of looking at something in Nexus, the next thing to really think about is, what does that really mean? You saw the comments collections earlier within the Sonatype product. And there's a lot of companies out there that do research. One of them might be Fortinet, who at the time actually highlighted some of the commons collections capabilities that were under attack at the same time that Sonatype found these things. And I think that's interesting because it tells you that there's interest in the community. You start to see it generate. It's not just that you have interest, but you also have the risk associated with whether or not that exploitable capability is something that's important. And then you can also find out where all that particular library is being used within every part of your application so that you can eradicate it and not necessarily see an exploit come to life when it could be hidden. And that's important because we see a lot of things like awesome CVE POC, where there's sort of a curated list of CVE POCs. And what I was saying earlier is that a POC is really a proof of concept exploit, where proof of concept exploits are actually a good way for a payload to be generated that shows and highlights that an application is vulnerable. So it's not just that you're going to find something, patch it, and then it's gone forever. I think that you have to have an artifact repository that helps you build a tree associated with that library to understand where all the places are that it could be, and then ultimately test your way through to get assurance that you don't actually have that code anywhere within your software. So we leverage things like this whenever we see something early on in the pipeline. If it gets patched, great. Sometimes patches take a while. And you might actually have to do something like V-patching, or you might even try to build an exploit to the next level so that you can test with it. Sometimes POCs don't do a full exploit. They actually just do an impaired exploit. That can be a scanner type of application. And so what we're always trying to do is kind of further it. And like I said, red team extreme so that we can try and get ahead of attackers. So that means you kind of build a hat trick within your environment. The hat trick here is really we put on the red hat, we figure out how we're going to break into something, we break into it, we prove it, and then we get it fixed as quickly as possible. Data's just not enough. Like, you could be getting lots of information. Tends to be that for most security applications, you get billions of events that get correlated, analyzed, and ultimately with hundreds of defects that come out of that pipeline. I think that it's important because you're going to distribute, depending on how many lines of code that your company has, you're going to distribute those defects so that they can be worked, and the faster they're worked, the less likely the ROI of the bad guy is actually going to be realized, because ultimately you've eradicated that problem from becoming an opportunity. And like I said, we're adversary obsessed, which means you're caring about things like motive, method, and opportunity. And in motive, method, and opportunity, if you just cut off the opportunity, a lot of times you don't have to worry about the motive or the method, because there's really no realization without the opportunity. I think it's also important to highlight some of the other talks that are out there in the industry. And, as I was thinking about doing this talk, I realized that there's a lot of stuff that's really interesting, and you can see some of the exploitable attack surface that's out there. There was a really great talk. I've left a link in here. I'll provide the slides. But I think DevSecOps lessons at OWASP is just amazing. Lots of information. One of the things that we learned early on is that if you have 100 developers, they'll generally be matched up with about 10 operations staff and 1 security professional. And what I just showed you is that 1 security professional has to hold down a lot of different tools and capabilities to be able to be valuable in this pipeline. That's very challenging. And so what we have to do is figure out a way to distribute the security knowledge within the development pipeline so that developers can make better security decisions and that they understand the adversary intent that's out there for their application. One of the best questions to ask is, how many adversaries does your application have? And I think that lessons like the ones at the OWASP talk that was leveraged here are really important, because they're going to highlight what you really need to be thinking about when you're testing. Another one to highlight is back in 2015, there was a full stack attack at RSA talk that was presented by Veracode. Super interesting. And one of the greatest parts about it was that they actually did this thing around attack maps, where it's very easy for an application developer to, instead of building a threat model, be able to map out the places where they know they may have taken risks within their application. And as part of this, if you are measuring from the security side whether or not there's actual interest, you might put out things like honey keys or honey configurations or honey parts of your application libraries, and really measure interest, engage it. Back when we did this, you can see that a lot of the experiments that we did produced an outcome within hours. Escalation of privileges took about 5 days, and I'm not sure why it took that long for somebody to escalate privileges, but the environments were all very cloudy, so that could have been why. Ultimately, what's great about this is that you see things like hours back then, but now it's really moments. A lot of the adversary capabilities have really started to become applications unto themselves, services where you can actually run them to be able to find things like exposed API keys or username password combinations. And so you see things like account takeovers. So this is a great talk where I think that if you're interested in learning more about how to actually hack a full stack, this was a great presentation. And then
Shannon, a little heads up, we got a couple minutes left.
Yep, I'm almost done. And then the security hierarchy of needs at RSA, which is basically the security hierarchy needs, is around how do you make application security and software security easier for a developer quickly so that they can be good at it. 80% of most problems associated with an attacker come into these 5 areas. So if you were to put something in front of a developer and you said, hey, if you just got these 5 areas right, you get 80% of the problems eradicated from your software. These are the 5 that we leverage. So zoning and containment, asset management, logging, authentication, and encryption. And I left a bunch of the links in here. This one was presented in 2017, and I believe it was also recorded, so very worth watching. Finally, if nothing else, I would say collaborate, 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 get into a community. One of the communities that I run is DevSecOps.org. The DevSecOps Days group is up and running now, so that's super interesting. And I would just say get involved, participate, science the heck out of things. Even look towards building payloads for some of the POCs out there, because the faster we test our code and eradicate opportunities, the better. That's all I have for today. Thank you. I'll be on Slack for a while.
All right. Great. I've got a little info here. So there's one thing I want to ask, and it has to do with how far ahead of the curve you usually are. You know, you were 2 or 3 years ahead of the curve on DevSecOps, and now you've started with the adversary. You've really become obsessed in the last 6 months to a year, and it's starting to notice. Do you think that's the next level we're working towards?
Yeah, I think we're kind of on a 4 and 5 scale now with DevSecOps at Intuit. So we're doing things like adversary, return rate. We're looking at and really beating up our code a lot more aggressively. I do think it's the next thing. And I think if you're not actually looking at adversary interest, you're probably missing the boat. Like, I think that it's great to build security into your pipeline, but ultimately the thing that's going to help you to tune your pipeline, and I'm being specific about that word, tune your pipeline, is around understanding adversary intent and interest, because then you might even be able to hone your skills towards making things more resilient within certain areas where adversaries are finding opportunities. And I think the last piece is really finding your ideal victim and really eradicating the opportunities that are presenting themselves most.
All right, great. Thank you. You can say hi to your friend Damon. He's sitting there.
Hi, Damon. Nice to see you.
So, Damon, come on in, say hi.
Hey, how's it going?
That's good. Shannon, you know, it's always, I miss seeing you around. So I hope that we get to see you more often when I'm in San Francisco.
I will see you soon, I'm sure.
Also, if you could, in the chat room, when you go to the Slack room, if you have any recordings you want to point to, or you do talk about adversary, I want to see those.
Okay, yeah, absolutely.
There's
going to be a lot more coming this year, so I plan on sharing.
All right.
All right. Bye, guys.
Bye. Damon, how you doing?
Mark, how you doing? Thanks for having me.
Oh, I'm doing good, thanks. It looks like we got a blank screen. I'm just going to put your face up there. How's that? Good. Always fun to talk to Shannon, right?
Yeah, that was great. I think I'll be taking my talk in a different direction, but I love the I love the deep dives.
Yeah. That's we've had a tremendous 2 days, and I'm love that we're headed down the home stretch, and you're going to tie it all together for us.
Just a small request.
Your topic is different than everybody else's because you come from a completely different angle. So I'm looking forward to it. I'm going to turn it over to you if you want to share your screen and get ready.
Will do.
I see myself, so you're doing good so far. There you go.
Look at that magic.
All right, I'll be in the background if you need me.
Sure. So hello, everybody. My name is Damon Edwards. I think why I'm here, I've been pretty lucky in my career. I get to see inside a lot of really interesting companies, from large, Fortune 5, sometimes Fortune 1 size companies to, high flying startups. My background, I was the managing partner of a consulting company called DTO Solutions. We specialized in kind of operations improvement as well as DevOps improvement programs, primarily focused on large enterprises and kind of translating what people see on the conference screens, stuff that works at, kind of massive scale. I'm also heavily involved in the DevOps community. John Willis, I think spoke earlier, was him and I brought one of the first DevOps days to the U.S. We also do a podcast. We're kind of like Game of Thrones. We make you wait a long time for new episodes, but we will do more. It's called the DevOps Cafe. You can get it on iTunes. It's basically a long form interview show. We bring people on who think have something really interesting to say, and we really dig in. And currently, I'm one of the co-founders of RunDeck. We build operations tools, and so across those different angles, I get to see a lot and really kind of form an opinion on what's going on in the industry. So when Mark asked me to talk, what's this talk about? He's he want to talk about, or I want to talk about, I guess we'd say, is really, how do you help people so they help you, right? And specifically here, it's how, as security professionals, do you help operations folks so they can turn around and help you? So it's really, we're going to talk about understanding the pressures that operations is on, and figuring out how to help them so they help you, and really do something special and different with DevSecOps, right? It's not just a redusting of or dust off of old ideas, but take a fresh look at security and operatability and how they work together. And I couldn't find a good quote that talks about helping people, helping you, or anything like that. So this is what I came up with. If somebody has a good quote on that, let me know. I'll fill it in. So I'm going to start with a quick little history, or I guess an observation on the history of DevOps, and specifically think about how DevOps started. Right, it's going to be Dev and it's going to be Ops. They're going to live in harmony. They're going to help each other out. It was going to be great. No borders, no colors, no walls. It was going to all be fantastic. But something kind of odd happened along the way. It really became heavy about Dev. Right. The focus came about the deployment pipeline, which is really developers' view of operations. The reality is there's so much more that goes on, post-deployment, right? Responding to incidents, maintenance tasks, performance investigations, building out platforms, scaling, lots of things, right? So, really deployment's not the finish line. It's really the beginning of 24 by forever, and a lot of things that need to happen. But yeah, we got very fixated on the dev side of DevOps. And what ended up happening is it's basically we got, in a lot of organizations, Agile plus some automated deployment. And that's better than kind of where people were before, but it wasn't realizing the full value. The companies that really did the balance of transforming Dev and transforming Ops kind of have leapfrogged over those who have fallen into just we've got better pipelines, right? So now here comes this DevSecOps idea, right? We're going to insert security into this pipeline, into its rightful place, right? And say, okay, now we're going to, include security in these pipelines as well. And, my concern is we're just going to fall right back into the same trap, right? Where now it's going to be really DevSec. We're going to keep talking about vulnerabilities and deployment pipelines and things like that. The reality is are we going to leave Ops behind again and not fulfill the full benefit of this, right? And my hope is to kind of make the case that security can really align itself with operations and help sort of take a holistic view on transforming. How do we get Dev, Sec, and Ops together so we all end up at a better, at a better place, right? I guess it'd be 1 + 1 + 1 = 5 or something like that. So I think the first important thing is to understand what is the mindset that operations is under today, and what do they really care about, right? So if you think of what's going to happen in operations today, they're in a tough place, and it's a proud bunch, but they're being squeezed between these two competing business pressures, right? On one side, you've got the pressures coming from the digital and the DevOps transformations, the go faster, go faster. On the other side, we've got the lock it down mantra, right? And it's don't be the next hack, don't be the next breach, don't be the next major outage. Lock this thing down. This is now how and where we do our business. And those two competing pressures are all come together in operations and are bearing down on operations. And operations is already operating at 100% capacity, and this is just going to basically squeezing people beyond the breaking point. And then here we've got security, right, which is one of those major forces that's driving the lock it down mentality. And it's not just application vulnerability security, but also security in terms of, how do we access these things, right? We're trying to relieve this pressure to get all these people into to help us out using these kind of DevOps and SRE techniques. But it's not just about locking down the artifacts. How do we lock down? We already want to lock down our environments, and how do we give people access to those environments? How do we, let the broader organization participate in this activity, right? So, security plays a huge part in both the pressure that's being landed on operations, and I think also we'll see it can help out, pushing for solutions here. So, what keeps ops under this pressure, right? What's really going on? We want to step into their shoes, and I think a lot of this actually, you can insert the word security here, and you're going to find a lot of these same pressures: silos, queues, centralization. And I'm going to look at each one of those real quick. So silos, right? So we use this word silo a lot in the DevOps world, right? And some people equate it with a team. That's not really the case. Really, siloed is about a way of working. So if you think about you're working, it's you or it's a few people on your team. You share the same backlog. You have the same management, sort of chain above you, which means you have the same priorities. You're all closely related, working the same things. So you share the same information or the same context, and you're often using the same tools. So that's great. You're working together in this shared context, shared mind space. But in the enterprise, especially, or really anywhere, nothing lives in isolation. You're always going to need something from somebody else, especially as you grow. And this is where the silos happen, right? So you need something, somebody else can do something for you, or has the information that needs to be done, but they're working in their own backlog, their own context, their own tools, their own priorities. And this is where the silo effects start to build, because we have all these mismatches, right? So there's context mismatches, right? People are thinking in different contexts, working on different things. There's process mismatches. The processes don't really truly align. There's tooling mismatches, and also capacity mismatches. Some people are oversubscribed. Some teams have plenty of slack time. And then probably as security professionals, you feel this a lot, probably. Things are getting thrown at you. You're being brought into things too late. It's all these breaks in context, breaks in processes, breaks in tooling, breaks in between capacity mismatch that really cause a lot of thrash and churn for operations, and security as well. So what happens is the org tends to become this siloed pool of functional specialists, right? We get these requests, they come in, somebody has to context switch off of something. They look at this atomic request, usually in the form of a ticket. They have to do something about it and then kind of move on. And these different functional areas, right? Security would be one of them. Think of the operations like network, storage, firewalls, the SRE teams, or whoever it might be, divided up into these functional areas, because very difficult. A lot of those context breaks keep getting in the way, and everybody's scrambling to do these one-offs. So, how do we cover for this, right? Well, the way that we cover for these silo disconnects and mismatches is this thing called the ticket queue, right? And we all know how well that works, right? How many times is it things sit in the queue until you get a PM to push it, or you fill out a ticket, you're not really sure what you're asking for, it gets kicked back to you and you have to wait longer, or you finally get something back and it's not quite what you wanted, so you then have to go and either work on it yourself or send it back. So all kinds of thrash and bad handoffs come with these queues. And the fact is, there's actually plenty of scientific proof, academic proof that queues are a very expensive way to manage the flow of work. This comes from Don Reinertsen, who his kind of book has the principles of product development flow. It really has kind of a cult following in the DevOps space, but really lays out why do things like queues and batch sizes, right? And those type of things. Why do they cause such problems, and kind of gets down to the math level, behind it, the queuing theory and whatnot. So he talks about queues and says, queues automatically, by their very nature, introduce longer cycle times, increased risk, more variability, right? Because people are working out of context from each other and doing these one-offs. More overhead. You have to manage the queues and manage all those requests. Lower quality, right? Because of all the breaks in the context, and less motivation, right? People get tired of doing something and then seeing it sit for days or weeks before somebody can do something. They can see it realized. So queues are naturally an expensive way to do things, yet it's the way that we do things, right? And it's the way things are happen in operations. And also, if from what I've seen from security teams, I'm an operations person, by trade. You see these same this same effect, right? The same silo-driven way of doing things. And from one other kind of dangerous things about queues is because people end up working out of context, they end up kind of becoming these siloed labor pools. You get a lot of snowflakes, right? And snowflakes, another kind of DevOps lingo for you basically each thing is a totally unique thing, right? And it might be technically acceptable or perfect, from that person's point of view at that time, but it's totally unreproducible and often brittle, right? So making a manual change on a server or doing something last minute to a package before you go and deploy it, all that manual intervention, all those kind of ticket driven requests generally end up generating all of these snowflakes. And the snowflakes, we see time and time again, it's just unintended variability, right? And unintended variability just injects, security risks all over the place, right? I mean, we've seen stories of, global banks that, forgot to patch one machine or left one library in place or, messed up one configuration setting and, bad things happen. So all this isn't just operational gridlock, but it also, leads to higher security risks as well. And then comes the idea of centralization, right? And something that we see a lot on the operations side, and from what I see from the outside, happens a lot on the security side. But looking at where decisions made, right? Who can take action? And what often happens is an incident occurs or something occurs, some decision has to be made over here, and we end up with a series of escalations, right? And eventually it gets to the point where you're far enough away from the keyboard, so to speak. It's the vice president level has to approve something, or a director, and they don't have this context, right? Their most common decision methods that they're employing is maybe similar history, right? Like, oh, I think this looks like something I've seen before, so I'm going to judge whether that's risky or not. And as we know what they say about complex systems, they work every time until they don't, right? So basing something on past history of a complex system is generally not. Is a kind of a foolish approach. Or general folklore, right? To know that, ooh, that's risky, that's not risky, or just what people feel about things. Like our network's got problems, so therefore we should never touch it, or things like that, or just mostly guessing, right? Just saying, well, that sounds like it's reasonable or not. So that's what we end up with a lot of. And is John Allspaw, who is a very well-known kind of operations practitioner. And now he's on the academic side as well, really looking at sort of human factors, human performance, see what causes and outages and disasters. He did this little thing at the DevOps Enterprise Summit last year, where he asked the whole audience, is this dangerous? Is this risky? Right? And people go, maybe. It's like, right. What if I told you it is just a line from a script that cleans out a directory in a content cache, right? That doesn't seem so dangerous anymore. Likewise, he said, well, is this dangerous, right? I'm just making this simple, case change in a code check-in. Seems pretty innocuous, right? But what if I told you it was a status check on a firewall configuration, right? And his point was that, all work is contextual, right? The answer to any of these questions is always, it depends. You have to have the context to make these decisions. And the people who make these decisions are the ones that are closest to the problem, closest to the action. Yet we time and time again employ this escalation chain that puts the decision somewhere over here in this kind of far corner. So, the key idea there is to, shift left that ability to take action, right? Push the ability to take action from this person, right? All the ways closest possibly as we can to the keyboard, to the person who's experiencing the issue, who really has the context or has the idea, right? How do we push that direction to them? But everything is set up in our organization to kind of keep these walls up. So, how can security help operations, right? How can we get security help relieve this pressure on operations? And why would we want to do that? Why would security want to do that? Number one, to get your new tooling in place, right? Tell them, hey, we want to inject ourselves into these pipelines. We have ideas to bring our automation and merge it up with your automation and provide a better future. Well, they can't get to that if they're kind of stuck under their own weight. So how to help the ops dig out of this is to say, well, how can we relieve as many of these pressures? And by getting rid of these things that get in the way and replacing them wherever we can with self-service, right? We've seen this work extremely well for deployment, but really it's kind of, in a lot of places, it's been limited just to that, just to, we've got this little pinhole into this kind of large, complex web of activity called operations. So the big question is, all right, well, how do we decentralize? How do we push that control down? How do we get this automation and self-service in place, start to decouple the organization? But how do we stay under control, right? And that staying under control is the part that, partnering with the security side can really, help prove the point and, kind of drive this home. So I think, to how do we get to that safe self-service place? There's a couple things to keep in mind. One is to think about, what really goes into an automated procedure, right? There's really kind of three parts to it. There's the ability to define that automated procedure. There's the ability to execute that automated procedure. And then there's the ability to govern that automated procedure, security, oversight, compliance, whatnot. And the reality is, traditionally, how we've always viewed automation is it kind of occurs within a silo, right? That someone needs something done. All three of these things, the ability to define, the execute, and the govern, happens within that operations silo. The automation is really for them, right? To do their job faster, so they can respond to these tickets faster, right? And kind of the first step is, well, let's experiment with what we call like rigid self-service, right? Meaning that let's set up the automation for people and give them the button, right? Here's a button you can push to do something. And that worked pretty well in the deployment case. I mean, it's actually a quite static automation. Let me give you the button to push it. But the reality is it ends up being a very limited use case because the effort involved with having to build and create this automation is quite high. And it's siloed within operations using their own siloed tools. So kind of the next realization is, well, how do we get these high velocity handoffs? Well, the only way that's going to happen is if we let the people outside, the requesters, let them define what they want to have happen, right? You can think of this difference as like, AWS, right? The old kind of Savvis style of hosting, you fill out a request form and you tell what kind of server you want, and then somebody has to go and figure out what that actually means and build it for you. Way too slow. Versus AWS, it gives you not only a way to run instances, but or any cloud provider at this point, but the most groundbreaking thing was you were in control. You can define your own AMIs. You can define your own configurations. They gave you the guardrails to do it in. They gave you the primitives to build it with. But you, the requester, was actually in control, right? So being able to move that ability over to outside of operations is going to make that relieve a lot of pressure from these high velocity by creating high velocity handoffs. And then truly, when you get to self-service operations, is when you can move both the ability to define and the ability to execute to the third party, to the people outside of, I guess the second party, the people outside of the traditional operations domain. And the companies you see that get really good at this, they get to the point where they're actually pushing a lot of that governance, right? They're saying, we're going to set the master rules. We're going to set what, can and can happen at a global level, but we're based on the business line and different risk profile. We're going to delegate as much of that ability to do your own governance or to find your own security policies, give certain people access to hold out, what can talk to what, push that to, out as well. Just basically offloading as much of the pressure off operations as possible, right? And really the key design pattern, that we see enabling this is this operations as a service idea. Effectively what we see time and time again is it kind of works like this. We have a central location, and we're pushing to the people who need something from operations, the ability to define those actions and execute those actions. But then on the operation side, they're keeping the ability to, to approve those, or some they'll define themselves. Others, they'll just be the approver of. This is usually where security often comes in, being able to do reviews of these, like code reviews, but actually looking at them as, looking at operation procedures as code. The ability to participate and collaborate on executing actions, right? Things like health checks, scaling things, responding to business requests for, turning things up, turning things down, routine maintenance tasks. Not every service is born, fully automated. In fact, most never get there. So a lot of routine maintenance tasks still have to be managed, from outside of the service. But they're at all times maintaining the security and oversight of that. And really, so that it's that key point there, that they're able to split the definition, the execution, the governance, and move it to where it's the most effective use of labor. So, kind of how does this work, right? So I'm throwing RunDeck in here just because it's a product that we have an open source version that we make. There's also a professional version, but you can build this with many different tools. This is something we see happen a lot in the industry. So kind of step one, they're establishing a secure operations hub, right? To say, this is the point where we're providing people with control, right? Our standard vocabulary for how do we start things, stop things, do different levels of health checks, any kind of ongoing operational tasks that need to happen, and combining with different observability and monitoring views as well. So it's kind of gives them that cockpit view that they can say, I have an option of things I can run, but I also have a view into what's out there. The people who set it up, once it's set up, the engineers get visibility into their kind of controlled or limited self-service. Operations can use it for their remediation procedures, and all along security and operations stays in control. Well, that kind of helps, but it's still a silo to set this up. So step two is we're talking about that high velocity handoff where we see people establishing an SDLC for their operations procedures, right? So, treating their operations procedures as code, running them through the same SDLC process, doing the same type of code reviews, except this time maybe it's more of an operations and security focus of these reviews, having a kind of a build process to it. This is where our friends from Sonatype and Nexus, one of the 2 points they come in here, helping to distribute and regulate the promotion of these jobs. And then, step three comes along as well. Now they've got this pipeline moving, and we've got our operations procedures are treated like code along with everything else, integrating with the rest of our operational systems, right? Which often that means ticket systems, right? Sometimes even going as far as to saying, have this service automate the ticket systems, to automate the ticket process. So we have a standard change. We don't have to always open a ticket before we run it. We can just have the system open it and close it, automatically. Or we can say, check and see if a ticket exists before running a procedure, or check and see if someone's assigned to it. Again, come back to our friends at Sonatype, all the kind of software supply chain and their intelligence around the security and control of the artifacts in the operational environments. We see the integration with that as well. So effectively, with this, you get the full kind of operations as a service experience. The product teams, if you wish, can be defining the procedures as they as they go. The security and operations is in control of who does what, or who can do what, and everyone's pretty happy. And then step four, where kind of security comes back in, is the ability to say, wait, let's reap the benefits of having this system in place. We now have all this automatic evidence collection. We have these different points of control. We know who reviewed things, who created the procedure, who can run it, where they can run it, when they can run it. We have kind of traceability through all of our policies and the approval trails of what happened. So what we're doing here is we're actually decentralizing control of operational control throughout the organization, but actually raising our security posture. Because we're in control of this process. So just to recap, kind of what I was talking about. Number one, understand the pressure on operations. Know that if you're going to want to change how you're tooling and your place in the organization, I think aligning yourself with their needs and relieving their pressures is going to go a long ways. And part of that is understanding the cost of these silos and queues, which goes for how you govern your work as well, right? That we have to get out of that. If you want to kind of be a full participant in the life cycle, you have to get out of this, ticket-driven, siloed way of working, because it injects too much cost and delay and chaos into the process. Shift left our control making and decision making as much as possible. Empower the people closest to the problem. And don't expect people further away to have better context than those folks. So how do we empower them with the right tools and the right controls to make those decisions, as well as lean on this operations as a service design pattern. I probably should put a link here in the deck, but if you go to rundeck.com/OAAS, OAS, or just look for operations as a service. There's links on there. There's a kind of like a book we wrote. We talk a lot about, we're really kind of trying to document this pattern that we see as we see it kind of happening across the industry, very heavily aligned with kind of DevOps thinking and what you see in the SRE movement. So rundeck.com/OAAS, I think will take you directly to it. You can read it on the web, or you can download a PDF. You don't have to register for the web thing or anything. And and then the last step is, if you align yourself and help operations get moving, you're putting yourself in a position where, you can really affect greater change from a security perspective, and, look at yourself as a kind of full participant in the life cycle and helping take a holistic view of making everybody's life better. And that is all. So thank you for your time.
Damon, I don't know how you could have come closer to the time. That was perfect.
Wow. I didn't even look at the clock.
No, nice as always, as always. I was talking to Sarah Elkins on the back channel. You might have heard Sarah yesterday from General Dynamics, and she is another one of the people that are concentrating on the ops part of DevOps, and she was very happy to see that big devs and little ops, because that's the thought process, right?
Yeah, and I understand it's more of a dev. What happened is we ended up with a dev towards ops perspective, and I think now it's time to look at the ops towards dev perspective, because I think we kind of missed a lot of things. And by focusing just on pipelines, we're getting a fraction of the benefit if we can look at what actually is ailing the organization as a whole. And security is a fresh new voice that can say, yes, we want to be part of the pipeline, but we want to help go end to end and get the value across the board.
All right, thank you. Thanks for stepping in. Great way to start winding down.
Thanks for having me, Mark.
All right, we'll see you again soon.
Thanks.
David, how are you? Come on, turn your mic on and say hi.
Hey, I'm doing great, thanks.
All right, let me focus on you there for a second. I have to say congratulations to B. Everything going smooth?
Everything's going great. So I'm here today, so nothing yet, but we're expecting in the next couple of weeks.
That's very exciting. Congratulations.
Thank you.
So we're here to hear what you guys, you and Mick, are working on with the TaskTop, right?
Yeah, that's right. We're going to talk a bit today about how TaskTop leveraged IQ Server to remove some license and security risk from our delivery pipeline.
All right, I'd love to hear it. I'm going to turn it over to you. I'll turn my camera off. You share your screen and we'll be ready to go. And I'll let you introduce yourself to tell everybody who you are and what you're working on.
All right. So as I said, I'm David Slater. I'm the manager here of the DevOps department at TaskTop Technologies. Like I said, we're going to talk a bit today about how we used IQ Server to remove some license and security risk from our continuous delivery pipelines. First, I'm going to talk a little bit about us to give you some context of why this is such an important topic for us. So we provide software for value stream integration. We support 57 different tools for integration, and just sort of on a high level, what that mostly means is we support real-time synchronization between these tools that integrate. So tools like Jira and HP Octane, IBM RTC, stuff like that. So today I'm going to be talking a little bit specifically about our journey to continuous delivery. We, as you see there, we provide software for 43 of the Fortune 100. So these are big enterprise customers. We're a distributed company. We've got about 160 employees spread between North America, Europe, and Australia. So for efficient communication is really important for us. So I'm going to be talking a little bit about how we were able to achieve that for continuous delivery. So first thing I really want to talk about is open source at TaskTop. We make very extensive use of open source in our products. In fact, if you just look at sort of file size, which is kind of a broad way of looking at it, where some of our products are up to about 80% open source. So this is a very big topic for us. we also have a lot of requirements with our customers. So our customers have very specific requirements for OSS, especially when it comes to licensing and security. There's concerns about copyleft, especially strong copyleft with our customers. So the reporting on this and proactive reporting is very important part of our system for us. And same with security. So we have our own internal security policy framework in terms of resolution time for CVEs, but we also have compliance requirements that we have to meet. When we went to transition to continuous delivery, we had a quarterly release cycle. So we were releasing once a quarter, and we would have service releases every week, but our major feature deliveries were once a quarter. And this really built in some very batched work into our process. When you're releasing new features once a quarter, you have a lot of freedom to take a little bit of extra time to do things. So one of the first things we actually looked at when we wanted to start transitioning to continuous delivery is where our bottlenecks were. Our target was to be releasing about every 2 weeks initially. And one of the first places that we saw a pretty big bottleneck and also a risk was our OSS security and licensing process. We had a very manual process. Like I was saying earlier, we distribute a lot of OSS. So we actually have, in one of our products in IQ Server right now, displaying about 700 components. So you can imagine what a manual process of monitoring CVEs and OSS license compliance might look like. So we did try to automate this with our homemade tooling when we were sort of a much smaller company, especially for the licensing side. But clearly we're not experts. That's not our wheelhouse. So we still had to have a manual process to ensure that that was working correctly. We also had a real lack of visibility, and this is where the value stream will come in. And I'll talk a little bit more about that later. But we had a lack of security and license visibility. So we had these manual handoffs and emails for approvals, and it was really slow. There was not really much of a self-serve aspect for approvals for new bundles to be incorporated into our product. And if anybody else wanted to kind of see what was going on, it was really difficult to be part of that. It was a very siloed process. And there were entire departments that were sort of disconnected from the value stream, even though they had a lot of input into what those approvals are. So for example, our legal department or our sales department who wrote the contracts with the customers, and anybody who is a security stakeholder. And this was really challenging for us, mostly because we did have so much OSS, but it's just a really challenging problem as well, especially if you're trying to do something like an in-house tool. We also have JavaScript, so node libraries, and that was challenging because licenses would actually sort of change on the fly, and that was really challenging for us. So we had sort of two aspects that I'm going to cover here before we went to IQ. So I'm going to break them into the security and license to talk about each one. So as I sort of mentioned earlier, we had developers creating CVE reports manually. And this was a big problem for a couple of reasons. One of the big ones is, well, that just really takes away time from feature development. You're not delivering a lot of value by, Googling CVEs for components or trying to make tools to make that faster. And really nobody liked doing that. It really was not a fun process. And the other problem that we identified here too is the process to identify and update the open source software for CVEs was really just too slow for continuous delivery. And I mean, the other big problem was the monitoring and evaluating these CVEs was a point in time operation. So you could go through this process and the next day it changes, but this is obviously not a process you could do every day manually. And as I was saying earlier, the rest of the value stream really had no visibility, and really what that means is our legal department, our engineering leadership, and even the developers themselves really had no visibility into parts of this process. It was really fragmented processes, and people had a really hard time understanding exactly how it worked. So you'd have a few people within the organization that understood it front to back. So you could get an interruption just from something as somebody going on vacation. So on the license policy side, we had that in-house tool I was talking about earlier, and because this isn't our wheelhouse, we're not experts in open source software license governance and security. So we would actually build in some issues into our tool because the developers didn't really understand the nuance of licensing. So really all that we ended up with was an automated tool that we had to check by hand to make sure that it was correct. And this ran outside of the delivery pipeline and outside of that automation. And our license policy was documented, but it often still required intervention. People either didn't really understand the license policy that was documented, or say we would update that license policy, and people would forget to check for updates. So one day they get something approved and that's good, and then the next day something changes slightly and they don't know about that because they're not going back and checking that wiki every day. I talked a little bit earlier about legal approvals as well. So legal approvals of these bundles happen outside of the development world. It was an email somewhere and you would get an answer back eventually, and it was slow, and it was and because we're distributed, you'd have developers in Europe, and so any sort of answer would take quite a long time to get a definitive answer back. So these were problems we really needed to resolve in order to go to continuous delivery. They weren't as much of a problem before, but they were. They didn't prevent us from releasing in our old cadence, which is about once a quarter. But they still did cause problems, but continuous delivery was a really nice forcing function to really address that issue. So we really needed to address the risk, especially if we're releasing on that fast of a cadence. We cannot be having that license risk and security risk of that process built into our delivery pipelines. So we ended up picking IQ Server because it was just a really good match with the technologies we use, the build technologies. We're a Java company that we use Maven for builds. We have Jenkins. So it was a really nice match for us. The development tool was also very nice because we also use Eclipse. And we also decided to actually use our own product with this, with IQ Server to solve this value stream issue that I keep referring to. So IQ Server was the really important basis for automation for us, and provided that side of it, where we use TestUp Integration Hub to really propagate the visibility of IQ Server. So what did we do? We integrated the security and license policies into our value stream, and I'm going to go into detail how we did each of these next here. But we also did enable developer self-serve. So in our operations department, we really try to strive for developer self-serve. And actually, the last talk was talking a bit about that. So really great, some really great examples there. And that's a really important concept for us because we don't want to have to scale our ops department to every developer hire. We can scale much better if we enable developers to self-serve for this type of thing. Right from the governance to actually proceeding with picking and using these bundles. And we were able to do that from the start with IDE integration, and then that carries through to our delivery pipelines and our Jenkins builds. And that was kind of the last step there, was to implement a release gate into our build system. So if anything did slip through in terms of our process and policy, we have sort of a last check before it goes out for delivery. So I'm going to talk a little bit about value stream management. And if you're not familiar with it, a really simple way to look at it is really just a series of events that have to happen in order for you to deliver value to your customer. So it came out of lean manufacturing, and it's kind of like the classic manufacturing example, but it's a little bit different for software. So actually, right now on the tassup.com landing page, we have a really great report from Forrester that goes into this in more detail. And their definition of it's a lot more detailed than mine, where they talk about it's a combination of people and processing technology that maps and optimizes, visualizes, governs business flow. And if you look at the image up above here, it's kind of an illustration of that. So you've got your product teams in the ideate over here creating ideas, and you have your agile developers, your testers, and your DevOps. You're doing your releasing and building, and then that's a feedback loop that goes to customers, and that feed goes back into your value stream to generate new ideas and new functionality. So this is sort of a different view of the same thing. So I'm going to talk about what our value stream looked like before we had IQ Server and Lifecycle. So on the top here is kind of the straight line view of it. You have our salespeople using Salesforce here, and they're generating ideas for our product development team who are using target process. Whoops. And that is then pushing out to our development team who are creating commits and builds, and then that's going out to our support team and our customers who are then using that product. And the reason I actually really like showing this type of diagram, because it shows the sort of the connections between the departments, and I think it illustrates the problem that I'm describing. So down here on the bottom right, we have what should be where IQ Server would sit, but at that time that was just an empty bubble. It was these lines sort of represent the connectivity between these departments. So this is one development team, this is another development team. So our Jenkins build and release operations, and we have our support up here and our salespeople. So if you follow how from left to right on the top, the way it goes here is you have your salespeople creating target process issues for requesting features, and those target process features are getting turned into Jira stories. And you have commits coming from Git here, and you also have some say security issues coming from over here, which is this manual security and license process. So what we really needed to do was to connect this bubble down here into our automated build system in Jenkins over here. But we also wanted better feedback back to our developers from that as well. But it also, by enabling that, gave the entire value stream, whether you're in sales or product or engineering leadership, better visibility into that process. And that was really important for us, because especially to enable this self-enablement of governance of the licenses and security, we really needed this to be visible for all parts of our development value stream. And one thing I'll point out here that is that our say our legal department who sets the license governance is completely disconnected. They're not anywhere in this diagram here. And same our salespeople are really only connected through these feature requirements, even though they're the ones that really help us or create those contracts with the customers that actually lead to the requirements and the IP governance that we have to set for the licenses. So IQ Server was that essential piece of automation that we needed to be able to monitor this, and we are able to propagate that out into our value stream by integrating it with these tools that the other departments used. So for example, I've talked about this a little bit. Our legal team, they're the ones that provide a lot of our license approvals. But also we just needed visibility into that and exactly what that was, rather than a wiki page with an enumerated list. IQ Server is great. You get that visibility into it right into your Eclipse IDE. You can actually see if a new bundle that you're updating to or a new bundle you're adding has legal approval right through the license policy. So that provided great visibility into that. And our sales team. So I mentioned earlier that we have bill of material licensing for licensing requirements for our customers. So before that sort of process was not really automated. It was a manual process along with that tool I talked about earlier to provide that list to the sales team. And it updated once in a while. And that was one of the big problems with going to continuous delivery, is we really needed that list to be correct for every release. And that release could be created from any arbitrary build. So for every build, we needed that list to be correct. When this was really disconnected from this process and not part of the value stream and not automated, it got generated once in a while. So it would be correct for every X builds, but not for every build. And that really helped us meet those contractual obligations by being able to automate that. And engineering, the big thing there that I've talked about a couple times is enabling that self-serve. They can pick their bundles. They know, they know what they want on a technical level, what provides the best, but they really needed better feedback about CVEs and licensing to make that process quick, but also not require intervention from other parts of the business to slow that process down. So now our developers in Europe working overnight, they can pick a bundle. They don't have to wait until our sort of main office where somebody is going to approve that bundle wakes up and approves that bundle. And same with security. Our security group has much better visibility now into what the outstanding issues are, if there are any, and traceability. Where are they in the product? Some of the research that Sonatype provides is really great for explaining what our vulnerability is, and just this continuous monitoring. I can't emphasize how important that is. Having point-in-time monitoring of CVEs was a huge problem for us, but continuous monitoring was a huge enabler of this process. So what did we do to integrate it into our value stream? We actually made use of the webhooks for policy events in IQ Server. So, a couple of use cases that we have, for example, is we update a license for an existing component. That's something we need to tell our customers about, which sales that our company takes care of. So what we were able to do through webhooks and IQ Server is to actually send them to TaskTop Integration Hub. So TaskTop Integration Hub has this product called Gateway. And what Gateway does is it'll actually capture webhooks for you. And you can do some transformation of that payload that's coming from IQ Server. And you can send that to these other systems like Salesforce to create Salesforce objects and Jira to create, say, tasks for developers. And this allowed us to really integrate it into the rest of our value stream and that tool stack that these other departments use. So one thing that we integrated very early on was that when we had a change in licenses, we could actually create a task in our systems to notify people of that we need to notify our customers. And it's the same thing there's some great integration for Jira as well that's actually built right into it, and we're able to use that a bit as well. But we really like these hooks because it gives us a really nice integration in TaskTop Integration Hub to be able to sort of transform and do what we want with them. And because we integrate with so many different endpoints, we can actually integrate different parts of our company into our value stream because they all use different tools. Like sales uses Salesforce, developers use Jira, and you could have other departments like security groups and stuff that will use other tooling as well. So the other thing we did is, and I'm sure you've seen this a few times throughout this conference, but we implemented a OSS policy in our delivery pipeline as well. So, if you've used IQ Server and Jenkins, you're going to recognize this. I've got a sort of an example here where we one day ended up with a critical CVE, and we've actually kind of made like a graduated fail. If we have a security issue of a certain criticality or license issue, we'll actually fail our build, and that will remain red until somebody fixes that. But if it's a less severe issue, we also have the option of not failing the build, but still notifying that there's an issue there, so that we can keep moving forward. This is really great for us because it provides that sort of last gate for risk management. So if our policy otherwise fails, somebody doesn't use the IDE integration and something sneaks through, or say one of those JavaScript libraries actually changes their license to a different type of license that no longer meets our license policy, we're going to find out sort of right away now, and we can stop ourselves from delivering that software that doesn't meet our compliance. This was, without huge manual intervention and basically saying, just to take a step back, in our old system, when we had these quarterly service releases, we would basically have to do this big batch job and make sure everything met our compliance and our policy. And then we'd have to say, okay, no more, bundle updates or whatever for the next week until we can get this release out. You basically have to, put a freeze on that to make sure that nobody introduced anything new. And that, really just blocked the release, the development process. I mean, and that was sort of unacceptable for us. So this is a really nice for us, especially in continuous delivery, where you're constantly on a release. It's a week till release sort of thing. We don't have to slow that process down at all. We can keep moving forward. And so this is actually just something that we actually extended Jenkins to do. We have a quality gate report. So this is the visibility again. So from the engineering side, this gives really quick visibility. And what we have here is like we have test reports. So each team can see how their the state of their tests. But we also have some columns here for IQ server for security and license. And you can kind of see an example here of that sort of graduated difference. So we have two products here, and you can see one has some less severe issues that need to be dealt with, and one actually has a release blocker in it. We don't want to send that out. There's a security issue that we need to resolve first. So we're still looking to improve the system. I think there's a lot of great areas we can still improve this. We're continuously improving this. We started with something really small, and we keep integrating this more and more with our tools. Some of the things we're looking at next is really improving that proactive notification and really automating it straight through. So right now we have it automated to sort of notify internally that there's been a change, but we're looking to see how can we extend that more in that integration with Salesforce to improve the customer notification automation. And then another area we're looking at is improving integration with our release note tooling for CVE updates to give better visibility to that as well. And this is sort of a tool that we're going to keep leveraging this way and giving visibility into the rest of the organization, because it is just really so important to our software delivery. So I just wanted to spend the last few minutes here talking about, summarizing what did we achieve with IQ Server. So this first point is a big one, and I can't emphasize how important this is, but that constant and automated monitoring of security issues. So, we really reduce the risk of having no visibility into the current status right now of the CVEs for those third-party licenses. And again, that was so important for us because we have so many of them. There are hundreds, so these things come up regularly, and it was a really difficult thing to monitor in point of time. Never mind continuous; it was basically impossible. And providing this policy gate for continuous delivery releases is part of that sort of self-enablement for engineering. So we don't have to be afraid of making changes to bundles around release periods and everything like that. So it allows us to keep that velocity up and not interrupt the development process, and while reducing the risk of taking those actions like doing bundle updates, because we know that policy gate is there, and it's a way of our legal department and our sales and our contracts to be able to communicate what that is. And it increased developer capacity to focus on delivering value. Whether that's actually just fixing security issues or delivering new features. Removing that time that was required to monitor this and to worry about it and to have this sort of siloed process where they were waiting to find out if their bundle was going to be approved or not, and then finding out it wasn't and having to start over kind of again. Really helped us to increase that developer capacity and move that somewhere else, more valuable. And also the integration automation of our security and license policies into our value stream. So no longer is there this wiki page that people don't notice that it gets updated. It's real time. Engineers can get immediate feedback. Our security team can see exactly what's happening. Our engineering leadership can also see exactly what's happening. And that's been extremely valuable for us, especially when we need to retain the velocity with continuous delivery. And really, just to wrap it up, IQ Server was hugely essential to automating this process and enabling continuous delivery at TaskTop. Without a tool like this, it would have been extremely, I would actually say kind of impossible to be able to deliver software this often. And have the confidence that we don't have this license risk. We're not distributing licenses that go against our licensing policy, and we're not unknowingly distributing bad CVEs and not fixing them in a timely manner if we weren't constantly monitoring them. So in the end, it was really successful for us, and IQ Server was a central part of that. And that is all I have to talk about today. Thank you very much.
David, that was wonderful. One of the things that people ask us about daily is how do we measure the ROI on using your tools? I mean, they can internally, they think they know, yeah, this is helping us. But it sounds, you said it increases developer capacity. That's an ROI line.
Yeah, absolutely. I mean, you get to focus on delivering that value. You're not worrying about something that really, frankly, is somebody else's job to make sure that we have this license policy and it's well defined. You can really focus on delivering that software. And it's kind of at two levels. It's the capacity of it, but it was also just a task that people don't really like doing as well. So it kind of has a double effect. Not only are you able to shift that capacity to the value, but you end up with happier people because they're able to focus on their jobs, and delivering that value.
I talked to Mick a little while back. It seems to me you guys have really moved quickly as far as implementation. And I say Mick from TaskTop, because he was saying, we're just setting it up, we're getting started, and I'll get back to you. Well, you just got back to me. It sounds like it's pretty awesome.
Yeah, and it was a big change for us. It was continuous delivery was really a developer change, but once you start getting into it, you realize how much of the organization actually touches. Like it really is a company-wide change, which is why it was so important for us to integrate this stuff into our value stream.
Well, thank you so much. Tell Mick and the team I said hi. It looks like you guys are doing great.
All right, thank you very much.
Thank you. Head for the Slack room, if you will. Say hi to everybody. Drop off your slide deck and answer a few questions.
Will do.
Great, thank you. Oh, I see Mr. Weeks is here. It's out of focus. Let me see if I can bring him in a little closer here. Try that again, Derek. Pull it back. It's a little bit out of focus, too close. A little bit more back. There you go. I found it. That's it. Derek Weeks is a Nexus hero. All right. Wonderful. And you got Bobby on the wall behind you. You just got it all happening, don't you? No microphone on you yet. I can't hear you talking. Derek, I can't hear you.
I was hoping you could focus in on this little Lego guy, or there we go.
Yeah, right there. There it is. Hold on. Screen cap time. Got it. All right, great.
Okay, so this, if you've gotten these by showing up to one of our shows, we have a whole host of them on our desk here at Sonatype. So last session of the day, super excited about this one. So it's I'm already a minute late, so I'm just going to get started and share my slides. And Mark, you can tell me if it doesn't work here, but hopefully it all comes up. I can find my mouse on the screen. Okay, that seems to have worked. And so, how's that? Can you see the slide? Hello.
Yeah, you're good. Ready to go.
I'm good. All right. So this is a presentation I've given a couple of different times, but I continuously update it with new data that I'm getting in. I want to share it with all of you this afternoon, and I will, of course, post it in the Slack channel when we're done here. It stems from a lot of the information that we've collected over the years in the DevSecOps survey, community survey that we talked about earlier today. And it also comes from the State of the Software Supply Chain report that we've published each of the last 3 years, and I will begin writing the 4th version of that report beginning next week, now that the Nexus User Conference is going to be wrapping up. So the journey here really starts with the first way of DevOps. It's something that we've all read in the Phoenix Project, released by Gene Kim and others in 2013. The first way of DevOps, as you remember, was emphasizing the performance of the entire system and never passing a known defect downstream. And I think that, as you've heard from a lot of the talks here from, David at TaskTop, from Barry at Fannie Mae, from Jasmine at Delta Airlines, and others that have been on with us throughout the conference here, their organizations have really embraced this concept. And part of embracing that is understanding how DevOps is really working within their DevOps tool chains, that you have feedback loops that you've built throughout your organization where you've automated the process to check something in. When you check something in like that, with each check-in, there is a trigger. And at a trigger point, in the first trigger points, if you're actually getting to these points here and there's something wrong, either a functional defect or a non-functional defect, you're automating the feedback loop for those particular problems and surfacing them back to the development teams to then fix and recheck in that code to move it down to the happy path here at the bottom, where we're able to go through each stage of the development lifecycle, testing and deploying into production. So when you think about this, never passing a known defect downstream says when you do, you're going to hit a trigger point that's red and send that automated feedback loop back. Well, this is extremely important in organizations that have and manage their software supply chains. And this is just what David at TaskTop was just talking about in the previous session. It's what a lot of our other customers have been talking about. And effectively, the way we look at this, and a good way to look at it as an analogy to manufacturing, the software supply chain really behaves like any other supply chain in a manufacturing industry. It has suppliers, or the open source projects in this case. It has centralized warehouses or the component repositories. So Maven Central, NPM.js, RubyGems.org, the NuGet Gallery, etc. And those components are absorbed by or downloaded from the manufacturers in the software supply chains. And that's really all of the software development teams that you've been hearing from throughout the conference here. Those components are then turned into finished goods or software applications. If you think about this, for open source components, they work with across this software supply chain as they're feeding into and through your organization. The same thing holds true for containers. If I create a containerized version of an application as a supplier, I put it up on Docker Hub, your development team downloads that container and deploys it into your environment. That also is effectively a software supply chain. Every single one of you listening to this presentation that has a development team has a software supply chain. And that software supply chain is working at tremendous volume and tremendous velocity within your organization. To give you a sense of the volume of supply that is out there, we've gathered this information from the State of the Software Supply Chain report that was published last year and the previous years. Almost 1,100 new open source projects come online every day. Across every version or across every open source project globally, there are 10,000 new versions of projects that release every year. Across the average open source project, they do 14 new releases of their code every year. So there's a tremendous amount of supply that of open source components that are out there across these different repositories, across these different open source projects. And this is helping us expedite the velocity of our DevOps pipelines, our DevSecOps pipelines, CI/CD development. Why create from scratch what you could download from the internet in a second that someone else has created for you? We've seen this velocity of consumption grow exponentially over the years. And in each year that we've been tracking the download requests from the Maven Central repository, When I joined 4 years ago, or over 4 years ago at Sonatype, we had just completed 13 billion download requests. Last year, we just saw 87 billion download requests from Maven Central. There's a huge amount of benefit, as I said, coming from this because it's making our software development efforts more efficient on a global basis. If you look beyond the Maven Central repository to what's happening in the land of JavaScript packages, the NPM repository is seeing amazing amounts of traffic. So this is a screenshot from Laurie Voss, who I follow on Twitter. He works at NPM. He posts stats regularly on this repository. This is from April, but I'll tell you, I'll walk you back to November 2017. So 5 months before this, he put out a tweet that said NPM users just downloaded 4 billion packages in the last 7 days. And literally 5 months later, he said, NPM users downloaded 5 billion packages in the last 7 days. The growth that they've seen is absolutely tremendous. And this is because, one, more people are using open source. There are more automated tools out there that are being used to download open source components to bring them into our organizations. And as we were discussing with Helen Beal earlier today, a lot of organizations are really kind of unaware of how much open source they're using in their environments. Even Barry Schneider from Fannie Mae had mentioned, before they did an analysis, they had approved 800 components to go into their environment. But when they did the analysis, they found they had 13,000 unique open source components in their application portfolio. So the volumes are tremendous. The result is that 80 to 90% of applications that you're building today are composed of open source components. It's not just a Sonatype stat. You've heard it time and again through the presentations here, through the various companies that have presented. And when you think about containers and containerization and how much Docker adoption, OpenShift, Amazon, Rocket, Kubernetes have come into play, there are more and more containers out there that are coming into our environment, not all of which we've created ourselves, but we're bringing in from external sources and the software supply chains that we use. But even as we see all of these productivity gains and efficiency gains in our development and operations practices, we need to know and be aware that not all of these parts that are being used are created equal. That some have known security vulnerabilities. As we've heard from previous presentations here, there are license risks associated with some of these components. Some of these components are really old, where many newer versions of those exist. So a component released 10 years ago might have 140 new versions that have been released on the market since. But I can tell you, a lot of those 6, 7, 10-year-old components are still being actively used in development today that we're seeing downloaded. So what is, when we track some of the data behind the hygiene around this consumption, we've been looking year over year at the percentage of vulnerable components that are downloaded, known vulnerable components that are downloaded from the Maven Central repository. In 2014, it's not shown here, but we were at 6.5%. We saw year over year declines to 2015 to 6.1 and 2016 to 5.5%. And in 2017, we saw 12.1%, or 1 in 8 components downloaded with known security vulnerabilities in these environments. And this is, we don't yet know why. We're still exploring why the percentages went up dramatically. One of the theories that's going around is that our data research practices have improved dramatically over the years as we've put more automation, more intelligence and machine learning around it, and we've gotten more sophisticated, that It may be that the previous year's numbers were understated because our data research was not as good at those points, and that we're now seeing a truer reflection of the number across the community. But it's still alarming, because if you're not tracking what's coming into your organization in terms of open source components, what's sitting in your Nexus repository, or what your automated build tools are pulling down, if you're not checking for the quality of those components from a non-functional standpoint, you may be electively introducing this risk into your environments. So, no one out there is pulling down 1 billion components into their environments. For this year's software supply chain report, and this is data that we'll publish later this year when the report comes out, but I looked at 7,500 different organizations. The average organization is pulling in 170,000 Java components, 3,500 of which are unique. And in this set, about just over 11% of those components downloaded had known vulnerabilities associated with them. Now, if you're like any of these organizations, or the organizations that have presented throughout the Nexus user conference here, you'll know, you're not just developing in Java, you're developing in Python, you're developing in .NET, you're developing in Ruby. So when you are, these numbers from 170,000 are boosting to 300,000, 400,000, or 500,000 components that you're absorbing into your organization that may vary by quality significantly. Right? So how do we monitor or manage these components coming into our organizations? As we've said before, there are 6 in 10 organizations that we've surveyed have an open source policy in place. This data comes from our 2018 DevSecOps community survey. We've seen this pretty consistently over the years that we've done the survey, that it hovers around 57 to 63% of organizations. Now, the interesting thing in this year's survey that we saw is when we ask, does your organization have an open source governance policy? Those organizations with no DevOps practice said, 58% of them said, yes, we have a open source governance policy. And 77% in mature DevOps organizations have a policy in place. But in the no DevOps practice, 46% ignore it. And I think that means the effective rate is about 23% of those organizations have a policy and their developers and DevOps teams are following it. In the mature DevOps practices, where you actually see more automated governance of open source policies, you see less of an ability to ignore it, because automation is difficult to ignore. When you're telling your developers and surfacing the information for them about license information, about security information, about the age of certain components that they're bringing into the organization, and you're doing that inside the developer tools, whether it's Jenkins or an Eclipse IDE or Visual Studio, it's hard to ignore it, and more people are complying to that kind of policy. So for the organizations that have policies and don't follow them, for organizations that don't have policies and are absorbing large volumes of open source components, we see these components, the vulnerable ones, making their way into production. So in Northeastern University last year, they did a report called "Thou Shalt Not Depend on Me," and they studied 133,000 websites that were using JavaScript packages as part of their web applications. And what they saw was that very popular versions of open source components were being used, that severely outdated versions of those components were being used, and many of the very popular ones were also vulnerable versions of those components, when completely safe versions of those components were available to them. The reality of this is, and it comes, again, this comes from our 2018 DevSecOps community survey, is that we're seeing more breaches related to open source components in development in these DevOps environments. So this year, 3 in 10 organizations had or suspected an open source related breach. This was, months after the Equifax related breach, when we're querying these people on, have you had or do you suspect a breach? But it's also 4 years after the Heartbleed vulnerability was announced. In 2014, we ran this survey right during the month of April. That's when the Heartbleed vulnerability was announced. So you would suspect that that huge vulnerability that received global attention would get more visibility and for the people taking the survey, and it would have boosted the numbers sky high just because of that awareness. Same would hold true if we held the survey in September 2017 when the Equifax breach happened. You would expect to see a bigger jump. But when that was 14% of the people that took the survey, to see 4 years later, we're 121% worse off, that more breaches are happening, more open source is being used, but it's not being governed as well. We're not keeping track of our software bill of materials. We're not looking at the vulnerability for this, and we're paying the price. And the adversaries know there's an easy path into these organizations to breach them through these components. So as the title of my presentation says, we're all Equifax. These open source components are making their way into production. And while Equifax was in the news in September 2017 for a breach impacting 145 million consumers and their credit details, at the same time, that particular vulnerability that they were linked to was from March 2017. In March 2017, if you look back at the news, Okinawa Power, the Canadian Revenue Agency, Apple, Japanese Post, the GMO Payment Gateway, those were all impacted with sites going down from a known struts vulnerability. We documented many of these in our State of the Software Supply Chain report last year. Then in March this year, India Post and the India Social Security system were also impacted by struts-related vulnerabilities, where they announced, either they directly announced or it was reported that they had struts-related breaches in those organizations. So months after the Equifax breach, we're still seeing struts-related breaches of vulnerable struts components being used in production. Equifax was not the only one that was impacted here. Now, if we look at the Equifax, I think we all know the Equifax story, so I'm not going to spend a ton of time on this, but I think one of the important things to recognize here is that the vulnerability related to struts in this particular case, the CVE 5638, was announced on March 7th. Equifax, the initial breach of Equifax was reported to be on March 10th. Equifax had 3 days to understand that the vulnerability had been announced and to update their systems in a way that they could not be breached. They had 3 days to take action. When you look at Gartner's report of how long it is between the time a vulnerability is announced and the time that a system is exploited from that vulnerability, in 2006, it was 45 days. 10 years later, it was 15 days. And last year, in the case of Equifax, it was 3 days. When I was in London a couple of weeks ago, Daniel Cuthbert from Banco Santander reported that from a criminal perspective, the hacker mind, the great hackers out there, if there's a vulnerability out there, they're able to get into your site or your applications within 8 hours, right? So if you think about how fast do you need to know, how fast do you need to be able to identify what you have in production, what's in your apps, what's a priority to fix, how fast do we need to be? It's not just about DevSecOps making us faster. It's about getting the fix when it's needed in faster. As I talked about earlier in the day when I was at a DevSecOps meetup at Fannie Mae, they had a vulnerable struts component in their production environment. And they didn't freak out. They just took their normal process to deploy a new business requirement into production. And that process takes 2 days for any business requirement. They just saw updating their struts component as a new business requirement. And it took them 2 days to update that, which would be under that 3-day window that Equifax saw. So the kind of crazy thing when you look at the environment overall, it's not just Equifax and Apple and the Japanese Post and Canadian Revenue Service. When we look at Maven Central and we look at the number of vulnerable components, versions of struts downloaded every month, in March 2017, it was just over 100,000 vulnerable downloads per month. That dropped the following month, following the vulnerability disclosure, to about 80,000. So there were organizations paying attention to, we shouldn't use the bad versions of struts, let's stop doing that. But then you see a very consistent, 80,000 or so per month downloads of vulnerable versions of struts. And in November, it almost peaked again toward 100,000 components. Now, you may say, like, yeah, I know struts is really bad. We don't use struts in our environment because it does have such bad hygiene. We're using Spring. And Spring actually has a similar pattern within its community. When we look at the vulnerable versions of the Spring framework, we see anywhere between 70 and 80 or so, 85,000 or so downloads every month. There was a major vulnerability discovered in the Spring framework back in September, and you really see very little trail off in percentage of downloads year over year. In December and January, there's less development happening during those times because of vacation time. So that's actually where you're seeing some of that drop just by the calendar year in this. But the volume of vulnerability of vulnerable components that are being downloaded when safe versions are available has been very eye-opening within our research. As we've shared before, there are companies that are automating security across their development lifecycle. And we're seeing this with DevSecOps practices and mature DevOps practices. Automated security is coming into the lifecycle, throughout the lifecycle, 338% more often than organizations with no DevSecOps practice. So DevSecOps is real. It's happening at scale. When we look at what security tools are being used in these organizations, when security is being automated, it's WAFs, it's container security, containers, again, being part of the software supply chain. Open source governance that we've been talking about, more organizations are deploying that in order to help them better defend themselves and deliver high quality software and not deliver known defects downstream. And when you're able to do this, you're actually able to improve the quality of finished goods that are going to market. So those with managed software supply chains, and this comes from our 2017 software supply chain report, are improving the quality of their applications by almost 70% end-to-end throughout their software supply chain, from what's being downloaded to what's being deployed into production, right? So the question is really not, can we build secure software? We absolutely can if we emphasize it, more. But when we don't do this ourselves, when we don't take the responsibility to know what's in our software, to be delivering higher quality software to market, we're going to be held liable for it. Everyone's seen the GDPR legislation. Article 25 in GDPR says you need to build quality in. You need to build security into those systems. The White House, the FDA, Department of Defense, Underwriters Laboratory, 18F, OWASP, the UK government, French government, German government, they've all introduced policies or legislation or regulations that are focused on you need to build security into your development lifecycle. And again, we've documented these extensively in our blogs at Sonatype, as well as our software supply chain report annually. So when you think about this, when you think about how do we improve our DevSecOps practices, how do we improve how we're building software, it's really about emphasizing the performance of the entire system, understanding you have a software supply chain, that you're consuming these components and containers, and understanding what they are and never passing a known defect downstream. So that's all I have for today. And I think I finished on time. And Mark and I are going to do the wrap up here for the end of the day. So I will post these slides into the Slack channel. I will be in Slack if anyone has any questions or follow up here. And thank you all for attending today and being part of the Nexus User Conference.
All right. Thanks, Derek. Derek's going to close down there and then be over here next to me. Or are you going to do it from there, Derek?
I'll come join you.
All right. So I'll see you in a minute or two. As I look back, I pulled up the schedule of what we've been through for the last 2 days, and seeing over 30 sessions, it's overwhelming to try to think about all the things and all the stories that we've heard in the last 2 days. I do want to personally thank all the companies that stepped forward and came through and really delivered content that's useful for the entire Nexus community. 30 sessions of practitioners. You had developers showing code. I was very proud of our customer service team. They did a great track.
Yeah, I got to miss it because I was running the other track, but I'll look forward to seeing the recordings for everything they delivered.
I see Chris Carlucci's in the Slack channel, been there all day. Thank you, Chris.
Yeah,
very much.
Much appreciated.
I had a couple good sessions while you disappeared, doing whatever you were doing. But David Slater from TaskTop, a remarkable story. It was great to hear that. I'm looking through the list. It's hard to mention everybody.
I kicked off with Barry Schneider from Fannie Mae, and a great presentation on what they're doing there, how they've introduced open source governance throughout their development lifecycle, how they've improved their code quality over the years, and what they've been doing there. Mohammed from Fox Intelligence.
I heard great things
doing, his live demo. You got to go back and watch it because he practiced that flawlessly, and the internet stayed up for him. So it all worked. But
he's a young guy. The demo gods were good to him today.
Yeah. So showing AWS and building a CI/CD pipeline with Jenkins and Terraform, Git, Nexus as well. Let me see who on throughout the list. So Stefania Chaplin, you have to check out her session. She did 5 demos in 30 minutes. Amazing. Went through Nexus staging. She showed Nexus firewall in a Ruby Gems environment. She showed a JavaScript software bill of materials. Really quick, but very straightforward. It wasn't rushed at all, but she's definitely a champion there in a session that I enjoyed there. James Wickett and Helen Beal, a wealth of information that they delivered.
James
and
was
shared.
a machine gun.
Always is, but I mean, the good thing is he uploaded his slides, so you can go back and read them in slower motion.
And Damon was the same thing. I know you didn't get a chance to see it, but Damon and James and Shannon Lietz, the real deal, the stuff that really can get you. I'll tell you what I was interested in seeing, because you and I get this asked all the time. The company gets asked all the time. How do you get ROI from using the tool? How can you verify the ROI here? And I heard a lot of times it has to do, I'll use David Slater as an example. The developer capacity increases so much when the tools are used like this that you can almost put a dollar value on the ROI there.
Yeah. I mean, we talked to Barry Schneider earlier today about, it was, not just bringing the tools in and what they were able to do, but he talked very explicitly about the pain points of when I started at Fannie Mae. It would take months to get a single component approved. Could take 3 to 9 months, and you either ignored the policy or you waited. but it would just take months and months to get anything done. He said, now we're doing things instantly, right? Now we're not wasting time. It's a better place to work. Like the cultural, the cultural patterns, the satisfaction of the development teams just from, we don't have to wait and we're using modern tools and we're able to work and we don't, we don't have to wait for people. They went from 100% manual reviews to 5% manual reviews. And those manual reviews are kind of elective where they say like, surprise, we're going to, look at your application now and do a manual review. But, they reduced manual reviews 95% because they've automated, not just with our tools, but everything in their DevOps pipeline.
You had something else happen interesting today that I heard about. I didn't get to see it yet. The Red Hat demo. Explain what happened there. That was interesting.
So so this was Siamak and from Red Hat and Curtis Yanko from Sonatype. They were doing a live demo. And in the live demo, they picked a component that was known vulnerable. And they said, we picked this. We can see that it's vulnerable because it's violated the policy. But we want to run this build, so we're going to waive that demo. And something happened where I don't think Curtis pressed enough of the right buttons to formally waive the component is to be, it's safe in this particular instance. So they ran the build. They were using Jenkins and the Blue Sky interface, which was really cool. They're watching the build progress, and then it stopped. It's a policy violation. You can't move forward. We're not going to move this into staging. And Curtis was like, this wasn't supposed to happen. Maybe I didn't do that right. And we weren't butting up. We were butting up against lunch, so there was no speaker after him. I said, Curtis, go back and change it, run it again. And he went back, he pressed the right buttons, but went through, and it really showed like policy enforcement works. Automation is hard to ignore. And it was kind of a living proof demo there that happened live. It was recorded, so you all can go back and watch it.
Another thing that hit me that I heard a couple times that I hadn't thought about before. It started with DJ. DJ Schleen from Aetna, if you watch that one. And I heard it echoed through a couple presentations, is people are not failing the builds. They're setting warnings at the build time so that the app can move downstream and still get work on it, and then work on it in the process instead of failing it in place.
Yeah, so this was shown in Siamak and Curtis's demo as well, that they actually showed how the policies are configured throughout the life cycle. But they showed early stage of the development lifecycle, they were warning. Later stage and staging and prior to release, they were breaking the build.
Right.
And we heard Barry say that Fannie Mae has gone to breaking builds because their developers are used to this. They started off by monitoring. They weren't enforcing anything. Then they moved to monitoring with alerts. Hey, developers, you're using something that's not good or not approved. And then they, matured further and went to, hey, we're breaking builds if you're using bad stuff. So it is part of the maturity curve and the process of adoption. Not everyone starts day one with breaking builds, even though it's functionally, possible. You got to get organizational buy-in and the cultural buy-in.
The other thing that I'm seeing to round out the whole 2 days is there are different versions of how you gauge the maturity of a DevSecOps organization.
Yeah, Larry Maccheroni, DevSecOps kind of scorecard that he used. Shannon Lietz had a DevSecOps maturity model that she represented as well. And I know there are other versions being built out there, but when you look at it, and we didn't have the GSA on, but they have a great, if you Google search,
that's
John Giardini and Naveen Vimbar, who's the CTO there. We just had him present a couple of weeks ago in DC, but they have if you look under DevSecOps guide for GSA, just Google that. You can find their maturity model there. Really super stuff, very detailed, in fact. So
that's a lot for everybody to catch up on.
Yeah.
Me too. I missed half because I was doing the other half, but from what I heard, I don't say it out loud usually, but I'm very proud to work here after what I heard the last 2 days.
It's it's really exciting. Not only were there exciting stories, one of the cool things for me in the tracks was we start here in Washington, D.C., we go to Toronto, we go to Los Angeles, we go to London, we went to Paris, we went back to New Orleans. So you see a lot of the people that we have in the community around the world that are presenting, that we're able to contribute here without leaving home, and to have everyone watching who was at home, who didn't need to travel. So we could meet any organization. We can meet any organization anywhere in this format. So super happy that we could reach everyone and not have to, force everyone to get on an airplane, stay in a hotel, find budget, and so forth. So I think this worked. I think we're going to do it again. I'm really happy to see everyone in the Slack channel.
Good night, Roman.
Yeah.
He's been up all night, 2 nights in a row.
Roman's been up all day, so really good to see him and others there. So thank you, everyone.
Yes, that's. I hope to do it again next year. I think it's a great way to do it. All right. Thank you, everybody. Please enjoy the sessions. The Slack channel will be open if you want to participate and continue the discussions. It's going to be here as you watch the presentations. Jump in here, ask questions, and we'll keep an eye on it.
And the Capitals game starts in 2 hours, so go Caps as they try and win the Stanley Cup tonight.
All right. Thank you, everybody.
Bye.